Okay, let's start this with a quiz. How many semiconductor companies are there in Malaysia? Anybody knows? Anybody want to take a guess? 200 plus. Okay. Any other guess? 50. Okay. 20. Okay. We're gonna go through the answer a little bit later. Which state has the most semiconductors company? Okay. How many silicon fab are there in Malaysia? One. Okay. You're just guessing, right? I mean, anybody know the answer? 20. Okay, we'll see. Alright. So this is the map of Silicon Malaysia. This is the map from Malaysia Semiconductor Industry Association. Okay. So here you can find some of the answer of the question that I asked just now. As you can see, we have semiconductor firms almost everywhere in Malaysia. On the Semenanjung, we have it in Kedah, Penang, Perak, Selangor, Kuala Lumpur, Negeri Sembilan, Melaka, Johor. Unfortunately, we don't have any in Perlis, Kelantan, Terengganu, Pahang. And then in Borneo, we have some firms in Sarawak, but not in Sabah yet. Okay? So the answer to the question just now, how many semiconductor companies in Malaysia? The right answer is about 250. Okay, so Kevin is closest to that. Which state has the most semiconductor company? So you guys all got it, it's Penang. So you can see there's a lot of company here located in Penang. How many silicon fabs in Malaysia? The answer is 7. Okay. So bonus question, which state has the most silicon fab? Which state has the most silicon fab? Kedah. Alright. Kedah has how many?
4.
How do you guys know?
Yes, half.
Okay, Kedah has 4. Two fab in Infineon, one in Sintera, and the other one is in AMS Australian. So if you're interested to work in fab, this is probably have to move to Kulim Kedah. All those Kedah fabs in Kulim. Okay. Alright, so my name is Azam. I'm going to be your trainer today. So I'm a custom layout and physical design trainer from the Penang Chip Design Academy. So I have 28 years of experience from Intel. I did mostly physical design from custom layout to place and route to tape out. So I tape out more than 30 ICs chip design project throughout my career. So I also have interviewed thousands and I've hired hundreds. So I hired, trained and taught hundreds of engineers. So it's my passion to transform engineering into physical design engineering. I received my Master of Engineering in Microelectronics in 2006 from Multimedia University and my Bachelor of Science in Electrical Engineering from Washington University in St. Louis in 1996. And also a holder of one patent. If you need to contact me, my contact number is below in this part. So this is just to share with you the project one of the last project that I did when I was at Intel. So this project is already out in the market, so that's why I can share it. So project name is Core Ultra 200S, or the code name is Arrow Lake. Okay. So the part that I did, so basically this CPU, this is a multi-die chip. So it has 4 die. There's a CPU die, IOE die, SoC die, and also the GPU die. Okay. So the part I work on, I own the layout automation for the IOE, and also half of the SOC. Okay? So, alright. The learning objective for this session is that by the end of this session, you'll be able to describe the semiconductor ecosystem and identify which companies involved in D&D Malaysia so that you know where to look for jobs in semiconductor. Okay? I will show you what are the things that you can consider when choosing your first job, so that you can evaluate your career option and what you need to do, what you need to have to be successful. And then on the third segment, we're going to go and build an ATS friendly resume so that you can use that to start applying for jobs. And then on the fourth session, we're going to do some learning on interviews so that you can ace your job interviews later on. Yes? So the content of this course, the first module is to understand the ecosystem. So I show you what the semiconductor ecosystem is, and then we share you with Malaysia National Semiconductor Strategy, and also the list of D&D companies in Malaysia. On the second module, I'll share with you how to evaluate the company so that you know that's the right company for you. So we're going to consider the company's culture, which type of job roles, and how to measure your skill set and other considerations. The third module is for applying the job. So we go through what documents are needed, how to build a resume, and where to search for jobs. The fourth module is about the interview. So we cover what to do before the interview, understand how the interview structure, how to introduce yourself. Then we'll do a technical interview demo and how to answer behavioral questions. Then we'll do a closing and following up. Okay. So after this four module, we'll do a Q&A, and then we'll do a summary and call to action. So this is going to be interactive lectures, so you can ask me questions anytime. Okay. Alright, so let's start module 1, understanding the ecosystem. So this is the semiconductor ecosystem. Actually, the semiconductor ecosystem is quite complex. Okay? A lot of people try to simplify it. So this is one of the models that I think is easiest to understand. So basically, in semiconductor, we have a design side, and then we have the manufacturing side. And then we also have another segment called the IDM, which is integrated device manufacturer. So this IDM, they do both design and manufacture. Okay, and then down below we have the outsource service, which is one of the main service we have in Malaysia. Okay. So on the design side, we have fabless chip firms like AMD, Qualcomm, MediaTek, Marvell, Broadcom, Nvidia. Okay. So all these companies, they produce a chip and they sell it out, but they don't have a fab. So they design, and then they outsource the fab and packaging to somebody else, and then the outcome is the chip that they sell. So you see AMD, they use in PC and data center, and then Qualcomm mostly in phones. And then we have a fabless non-chip firms. So this type of company, they do chip, but only for their own consumption. Okay. For example, Meta, Facebook, right? Apple, Google, IBM, Tesla, Amazon, Microsoft. So like Meta, Facebook, they produce a chip for their own server, Facebook server, right? So that they can to make Facebook faster and more efficient. Same with Apple. Apple produces chip for iPhone, MacBook, but they don't sell that chip to other people. They only use it for themselves. Okay. And then we have the IP and design software companies. So this is a company like Synopsys, Siemens, Ansys, ARM, Cadence. So like Synopsys, as you learn, create a lot of tools for design, like custom compiler, Fusion compiler, design compiler. Okay. And then ARM is known for the IP, so they create the ARM core for people to use the phone chip and things like that. So on the manufacturing side, we have foundries or fabs. So some of the big players is Global Foundries, TSMC, UMC, SMIC, Samsung. So in Malaysia, as we mentioned just now, we have Infineon, we have Silterra, and AMS Australia. And then we also have a company that do the testing, packaging, and assembly for the chip that we fabricate. So this is a company like TER, Amcor, Technology, Agilent, Lattice, and Foxconn. Okay. This company, they don't fabricate, they only take the fabricated chip and package it, put it inside a package, and test it. Okay. And then we also have equipment vendor, KLA, ASML, Tokyo Electron, Applied Materials, and also Lam Research. So we have a big Lam Research in Batu Kawan. So they build the machine to fabricate the chip. Okay. So on the IDM side, we have companies like Texas Instruments, SK Hynix, Analog Device, Infineon, Micron, Intel, and Samsung. So this company, again, they design their own chip, they manufacture it, they fabricate it themselves, and then they do the testing, packaging, assembly also themselves, and then they sell it out. Okay. Of course, Infineon, the biggest one is Intel, probably for now. For the past decades. But now Intel is still struggling. Okay, so to support all this activity, we also have this outsourced design services. So because sometimes this firm, they don't have enough engineers to help them to design, so they outsource it to outside company. Okay. And then we have also outsourced semiconductor assembly and test, OSAT. So these companies, they help to do the packing, the testing, packing, and assembly as well. Okay. Any question on this? Okay. So how many of you have heard about the Malaysia National Semiconductor Strategy?
Produce 60,000
So you heard before that?
Yeah.
So it was launched last year by our Prime Minister. So it's a 10-year plan in 3 phases. So there are 5 targets for the National Semiconductor Strategy. First one, we can have is to have 5 billions of combined investment on all aspects of semiconductor. But they can focus on advanced packaging, IC design, manufacturing equipment, and also on the FDI, focus on wafer fab and manufacturing equipment. Okay. So the target is to create 10 Malaysian companies in design and advanced packaging. So this company need to have a $1 billion to $1 billion revenue, and at least 100 plus high revenue, means more than 1 billion companies. So hopefully these companies will pay higher wages for Malaysian workers. So the third target is to become a global semiconductor R&D hub with world-class universities, corporate R&D, and center of excellence. The fourth one is the important one, the most relatable to us. So to train and upskill 6,000 high-skilled Malaysian engineers. And to do that, they are going to target to allocate about 25 billion to implement all these NNS initiative. So why is this important? So right now, if you look at into just now we go through the semiconductor ecosystem, right? And then you can see, and actually all the activity doesn't have the same value. So the OSAT, which is the assembly, test and packaging, only contribute about 6% of the total semiconductor value. And then Fab 24% and D&D 50%. So Malaysia is very strong in OSAT. We have a lot of players in OSAT, but we have less players in Fab and D&D. That's why we're going to move on the value chain, create more fabs and more D&D firms in Malaysia. And why is this important to you? So you can see this is the 25 billion allocation, right, under strategy number 4. Out of that, 1.2 billion has been allocated to train and upskill 60,000 engineers. Means about 20,000 RM per engineer. So how many engineers work in semiconductor currently? So overall about 90k, but the one that do D&D is about 9 to 10k, 10% of it. So you can see, you can do the math. So overall we need 60k in 5 years, and D&D about 10k more. We need to double that. So who are these engineers will be? You are. Yes. So that's why we create this Penang Chip Design Academy. Part of it is to support this strategy, train up more engineers to do the R&D work, D&D work. Okay. So this is a list of D&D companies in Malaysia. So this list is not exclusive, and actually this list is only capture companies in Penang. So even in Penang we have about 40 companies already. And if we have companies from KL, probably another 10 to 20 more. So there's a lot of companies involved in this D&D. If you see any names that you're familiar with, or any companies you are targeting to get a job at? Okay, some of it are local, some of it are international. Okay. So how do you, so we go back to the question, how do you choose which the right company for you? So that's what we're going to cover in module 2. So the first thing maybe what you want to do is try to consider what the company's culture. So different company has a different culture, right? I mean, you may not be able to fit into just any company. So the first type of company that we have is multinational companies. We call it MNC. Okay. Example is AMD, Intel, Infineon, NetEase, Microsoft, Microchip, Latera. So if you go to MNC, they usually have very large workforce, very organized. They have a structured management and training, and very strong company culture. Usually they offer the best workplace benefit, but the salary less competitive. Usually MNC offer average salary but with a very good benefits. And then most of the time the roles are very well defined and focus on specific processes, tools and flow. This means that when you join, if you join as a custom layout engineer, you're probably going to work on custom layout only, and then on a very specific block. Okay, you probably don't have a chance to try other things as part of in the design field. So the next one is ASIC chip companies. Okay, so for example, we have All-Chip. This is a Taiwan-based company, a Taiwan headquartered company. And then we have Hanik from Singapore. We have a Star 5 from China. So Star 5 is doing RISC-V chips. You guys know the RISC-V, right? So it's a new CPU architecture model. And then we have a Canon, also headquarters in Singapore. So they do the Bitcoin mining chips. And then we have Nexperia from Netherlands. So Bala used to work in Nexperia as the second design director. Okay. So if you go to this company, they are a smaller team. So usually you're closer rapport with your teammates. Okay. The office also is in a smaller location. Okay. Some of them are in Brisbane Mall, some of them are in a smaller building. Not, okay. Okay, so the third type of companies you can go through is the outsourced design service company. Okay, so we have some of Malaysian-owned companies. I'm sure you heard about Hopstar, Skychip, Infinex, and Sofix Automation. Okay, so this company, their engineer help to support design work for other companies, like for AMD or Intel. And then the biggest player in outsourced design service is actually from India. So we have a lot of Indian company here. For example, Wipro, UST, Quest, Bit Silica. Okay. But they also outsource their engineer to help other firms to design with the design work. So again, this is usually is a smaller team, so you closer rapport with your teammates. One of the advantages is that you get exposure to many processes and flow, as it depends on customer. So maybe you may support, for example, you may support Intel for 3 months, and then the next 3 months you will support AMD, and then both companies are not using the same process or the same tools or the same flow. So you have to relearn everything. But the good thing is that you learn a lot of things. Enrich your experience. So the downside is the anxiety of job security because this company based on the business from other company. So if other company decided to terminate their contract, they also probably will have to let you go if they cannot manage to find new job for you. You look like your question. Okay. And the last one, we also have EDA companies here in Penang or in Malaysia. We have a Synopsys, Cadence, Siemens. So most of the company that the position they have here is on field application engineer, which means that you work. Sometimes when EDA company customer face an issue, they refer back to the EDA company, so somebody has to go in and debug. For example, like you're doing custom and then suddenly your AVS keep failing, but you do not know why. So So maybe at that time you go back to DA companies and ask them to debug. Why not? Because you already exhaust your debugging skill, still cannot find the reason. It could be a bug too. So. Okay. And then we have EDA companies, local vendor. So mostly this local vendor, what they do is they do the sales and trading on behalf of the EDA companies. Okay. And their income is from the commission that they get from the sales and also from the trading. So we have a few companies like that. So we have an Emerald system and also ICE. Okay. So next thing to consider, which job role is suitable for you. Okay. So before you understand which job roles is suitable for you, you need to understand the design flow roughly, right? So mostly we start with architecture specification. Okay. So this is there will be a team of the company who will figure out what type of kit that we need, and then they put this into a document. So this document will tell what you need to design. Okay. And basically there are two ways to design. One way is to write the RTL. RTL is register transfer logic. So this is like coding. So you code what you want to design using a language called HDL. Okay. So once you get this RTL done, you pass to two teams. One team is called the pre-silicon validation. So this team will validate, make sure the RTL that you code will perform as what you intended to be. So the pre-silicon job is the pre-silicon validation job is to look at the RTL, figure out how to test it, and to make sure that it's going to work. So the other thing that the RTL will be passed to is called the physical design. Okay. So in general, physical design will refer to people who took the RTL, synthesize it, and then do the place and route, and then tape out. Okay. So it might. I know it may be confusing because we're doing the custom layout also consider physical design, but most of the time you go to the industry, physical design will refer to the place and route part of the design cycle. Okay. So the other way to design the chip is doing the circuit design, like what you guys experienced in this course, right? So basically, there's an engineer who will do all the circuit design, draw the schematic, where the NMOS and PMOS going to be. And then this schematic will be passed to the custom layout. Custom layout draw the layout. Okay. And then when both sides are ready, then we'll take it and do the integration and tape it out. I think Mr. Bala already go with you, right? So after you tape out, you send it to fab, and then after fab is done, they send to manufacturing, to assembly, test, and packaging. So the end result is the chip. Yeah. So once you get the chip, then there will be a team for the post-silicon validation. So this team will validate that the chip will work as what they intended. Okay. So those are basically the type of roles that's available for newbies, for new college graduate. We have the RTL design, and then we have physical design, which we do the APR, automatic place and out. And we do analog circuit design, the custom layout. Custom layout also, they can cover both digital and analog. And then we have the design automation. So design automation, the job is to make sure that the EDA tools is run correctly, or to provide, to do some automation. So the design automation will work from beginning to the end. So there will be design automation work for RTL, for circuit design, for PD, for custom layout. Okay, and then we have a pre-silicon validation to validate the RTL, and also post-silicon validation to validate the actual silicon. Also, if you are looking for a job later on, you probably want to look at graduate training. So graduate training is just a general term that we use for new college graduate. Okay. Some company use for a new college graduate. Okay. Any question? Okay, so who works on which part? Can you tell from this diagram which team works on which part? RTL design. So usually RTL design and physical design, right, they work together. So usually when you see on the die, you can see this, the black section here. So usually those belongs to the RTL and physical design because they are using standard cells, right, to place. So standard cells is very small, so you kind of see like very thin on the die.